Okay, good morning, Professor David J. Delosreyes. Okay, at September 8, 2023. The time is 3:07 EM. EM. Okay, my topic for this morning will be a continuation of my long video format discussion on college algebra. So this will now be lesson number 55. We are running smooth. We are almost done with college algebra. Okay, I've got another topic, guys. It could be maybe analytic geometry, maybe. Analytic geometry. Okay, let's proceed. My topic for this morning will be a continuation of my long video format discussion on college algebra, and this will now be lesson number 55, and the title of the topic is Binomial Theorem. Binomial Theorem, it's coming out on this short video, so for those of you who are studying binomial theorem, this is it. This will be the concept on how to expand a given binomial term. That's why it is the so-called binomial theorem. It is used for expanding a binomial term, okay, or binomial expression. There are two solutions in the expansion of a binomial expression. The number one solution is actually by using the so-called Pascal's triangle. The second solution, that will be our next topic, the next time around. Okay, I don't want to overload our minds, so we take it easy. So the solution I'll be presenting tonight will just be simply the solution by using Pascal's triangle. Mr. Pascal is actually a French mathematician who invented the so-called Pascal's triangle, okay, for finding the coefficient of the expansion of a binomial expression. Let's try to construct the so-called Pascal's triangle. It's easy to do. We'll just place 1 over here. Then below 1 we place 2. The other ends will be 1 and 1. Okay. Next one will be, the par ends will be 1 and 1. The middle terms will be the sum of 1 and 2, that will be 3. Next one will be 2 and 1, that will be 3. Par end is 1. First par end is 1 over. Next one. Par end, first 1, the last one is 1. So the middle terms, okay, 1 and 3 will be 4, 3 and 3 will be 6, 3 and 1 will be 4, par end will be 1. Okay. Next one, par end and par end are both 1. The middle terms will be 1 and 4 will be 5, 6 and 4 will be 10, 6 and 4 will be 10 again, 4 and 1 will be 5, par end is 1. Okay, so meaning to say, for n equal to 5, 1, 2, 3, 4, 5, 6, there are 6 terms. So if both par ends are 1, there should be 4 middle terms, right? Let's proceed with the n is equal to 6. Par ends are again 1 and 1. Okay, the middle terms will be, this is 6, right? So there will be 7 terms, so there will be 5 middle terms. 5 middle terms, 1, 2, 3, 4, 5. So to bring out these coefficients, just follow the preceding row, right? 1 and 5 is 6, 5 and 10 will be 15, 10 and 10 will be 20, 10 and 5 will be 15, 5 and 1 will be 6, par n is 1. For n is equal to 1, the total number of terms is actually 7. 7. Is it 7? 2, 1, 2, 3, 4, 5. Oh, 5. there will be pi, right? So actually, there is a middle term. If n is equal to 6, there is a middle term. The middle term is 20. So if you try to notice it, after the middle term, it just repeat this one. But there's no problem. You don't have to memorize that one. Just add the sum of the preceding rows, and that's it. Okay, we will repeat it for the last time. This one here is actually the sum of 1 and 5. This one is 5 and 10. This one is 10 and 10. This one is 10 and 5. And this one is actually 5 and 1. The last one is the far end is 1. Oh, that's the way how to build a Pascal's triangle. So even though you are expanding a binomial term expression to the 100 to the power 100, we could do it, but you must have to do first your Pascal's triangle. It's a lot of work, but that's the proper way how to expand by using Pascal's triangle. But in real life, there will not be so much significance in real life. This one. This is just pure mathematics. I've been teaching differential equations in advanced math, and there are no such applications involving binomial problem or binomial application problems. So this is just what you call this, a part of the subject matter algebra. That's why we discuss binomial theorem. But in real life, there are not so many application problems using binomial theorem. Okay, let's try to bring out the annotations. The observation from the Pascal's triangle. Okay, number 1. The total number of terms, expanded total number of terms. Okay, it is actually equal to n plus 1. Meaning to say, if we are to expand a, what you call this, binomial expression like an a plus b quantity square, okay, if we try to expand this, it falls under this, right? That is when n is equal to 2. That's it. If we try to expand it, how many terms? 1, 2, 3. So it is actually n plus 1. The total number of terms of the expanded answer will be n plus 1. It's always plus 1. Except for the first one. Because for the first one, there is no there is no binomial term to expand it, okay? So we start with n is equal to 2. For n is equal to 2, the total number of terms that are expanded is actually 3. 1, 2, 3. So under our annotation, the total number of terms that are expanded is actually n plus 1. Okay? Oh, what's next? The powers of a and b, the given example should be the Pascal triangle for a plus b to the n, okay? Because we are mentioning n here in a and b, okay? We have to expand an a plus b ratio n. For annotation number 2, the powers of a and b in its term equals n. We could not, what you call this, visualize this one not unless we go to the example. Later on, when we reach annotation number 2, I will try to show you this one. Annotation number 3. Am I still on camera? Powers of A, okay, it will start with n in the so-called descending order till it reaches the value 0. Okay? And the powers of B, the second term. Okay? It will start with 0. It will go in the so-called ascending order, increasing order, till it reaches the value n. So, under annotation number 3, the last term or the last number is actually without a, and the first term has no b value. Okay, meaning the last term is actually without a, and the first term is actually without b. Okay? Okay, let's try to bring out an example problem using Pascal's triangle. So the key to the solution of expanding a binomial expression is actually by using the Pascal's triangle. So the number one requirement is actually to be to what you call this construct or build the Pascal's triangle. If the value of n is just actually up to 5, okay, there are persons in which they memorize these ones, okay, up to the n equal to 4, they memorize this one, meaning the coefficients for the expansion, if you've been solving problems, what you call this many times in algebra already, I think you could memorize this one. For a binomial, it is 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. If you could memorize up to n equal to 6, that's up to you, right? But for me, if I cannot recall it, I will just construct the Pascal's triangle. But for me, I could also memorize up to n equal to 4 maybe. Because for n is equal to 2, that's only 1 to 1. For n is equal to 3, that will be 1, 3, 3, 1. These numbers are actually the coefficient of the expansion, okay? Okay, let's try to bring out an example problem. Example number 1. Am I still on camera? Example number 1. Expand using Pascal's triangle. We are given the binomial expression x, the quantity x minus 7y raised to the 4th power. So for this given problem, the value of n is equal to 4. And if we try to expand this one, under annotation number 1, the total expansion should have 5 terms. 5 terms, excuse me. It should be 5 terms. This is 1, 2, 3, 4, and 5. So that's annotation number 1. What's next? The powers of a and b in its terms equals n. For this, we could see it, right? The powers of a and b, for the meantime, the given problem, the value of a is actually equal to x and the value of b equal to negative 7y. Because a and b is just a representation. So if you are solving a problem, don't always think that the given expression is actually in terms of a and b. It depends. So a and b in here is just a representation. Okay? Number 1, what do you call this? Number 1 way to solve this one is actually to build the Pascal's triangle. But if you memorize up to n is equal to 5, there's no problem. No, n equal to 4. The coefficients under n equal to 4 is actually 1, 4, 6, 4, and 1. So we'll try to bring that one by using the Pascal's triangle. We start with 1, beneath is 2. Okay, per end will be 1, 1 plus 2 will be 3, 2 plus 1 will be 3, this 1. Okay, next one, per end, this 1. Next coefficient will be 1 and 3, this will be 4, 3 and 3 will be 6, 3 and 1 will be 4, per end will be 1. That is for n is equal to 4. The rows that will be needed in bringing out the coefficient of the expansion. So meaning to say the coefficient of the expansion will be in the value 1, 4, 6, 4, and 1. First term, second term, third, fourth, fifth. There will be 5 terms because it is n equal to 4 and the total number of expansion is actually 4 plus 1. So if we now try to expand this one, okay, we will rewrite this one. It will be an open bracket x plus open quantity negative 7y all raised to the 4th power. So this is actually our a and this is our b. Right? So we take note of the sign because in the given original, what you call this binomial expression, the operation is plus. But what is given in the problem is that there is a negative here. And to satisfy this one, we will rewrite it as like this. So meaning to say a is equal to x and b equal to negative 7y. Okay, that's very dangerous because if you don't include the negative sign, there's a problem. Your solution will be wrong. Okay, let's try to expand. The first coefficient is 1, right? The first term will be an a to the fourth power. The power here is n is equal to 4, right? So the power of the first term should start with n. So this will be 4. Okay? It goes to 3. It goes to 2. It goes to 1. Then it goes to 0. The coefficient, I just follow this. Right? So this is 1, 4. This is 6. I'm following this one. This is 4 also. And the last one, the coefficient is 1. For the coefficient of y, it will be like this. The coefficient of y, it will start with 0. Then it will go to the value n equal to 4. Okay, let's try to see. On the first term, the second term, which is b, is actually negative 7y. The power is 0, right? Next value after 0 will be 1. So this is negative 7y to the first power. Right? Next one. This is negative 7y to the second power. It is increasing. It starts with 0, increasing in value. Right? Next one. This is 2. So this will now be 3. Right? The last one, it will be negative 7y to the fourth. This is now the terminating value because this is n actually equal to 4. So for the second expansion, it will start with the power 0 till it reaches 4. Okay, then try to expand. For the coefficients, we have already identified the coefficients, right? So this is 1, 4, 6, 4, and 1. So the problem now is just the coefficient of the final answer. For the first one, 1 times x to the 4 minus 7y raised to the 0 power is actually 1. So this will just be simply x to the 4. The first one is x to the 4. Right? What's the next one? The coefficient of the second expansion. This is positive 4 times the negative 7. So this the coefficient of the second term will be negative 28. The sign should be negative because this is plus, this is minus. And the variable thing is x cubed and y. So if you try to notice it, 3 plus 1 is actually equal to 4. 4 plus 0 is also equal to 4. That's the one I'm telling you here. And 2 and 2 is also equal to 4. The sum of the powers of the first and second terms equal to the value n, right? That's a check. This one, it is 1 plus 3, that's still 4. And the last one, 0 plus 4, it's still 4. So we are correct with the exponents of the first and second terms, except for the coefficients. Let's try to compute for the coefficient of the third term. The third term is actually this one. 6 times, this is negative 7y quantity square. So we will square 7, that will be 49 times 6. Okay, so the coefficient should be negative 7 square will be positive, right? So the sign here will be plus. And 49 times 6, that will be 294. X square, y square. Next one. Where's the next one? Oh, this one. This is 4, but this negative 7 is actually raised to the third power. Third power, that will be 7 negative y to the x, 3. It's a negative value, negative 343. You are computing for the coefficient times 4. So this is 1372. It should be negative because negative 7 raised to the third power is actually 7y to the x third power. It's 343 times 4. So this is a minus and a plus. So this term here is with the coefficient 1372 x, y, cube. And the last one, this is 1. X to the 0 is actually 1. So the only remaining value is actually negative. We will compute for the coefficient. It will be 7y to the x to the fourth power. That's 2401. So the coefficient of the last term will be 2401 y to the fourth power. So this will be the final answer. X to the fourth minus 28x cubed times y plus 294x squared y squared minus 1372xy cubed plus 2401 y to the fourth. You could check it. The powers of x and y for the first and second terms in all the terms is equal to n. Right? Oh, that's the proper way how to expand this given problem by using Pascal's triangle. So the number one step is to build the Pascal's triangle so we could determine the coefficient of the terms on the expansion. Okay, next problem. Am I still on camera? Expand using Pascal's triangle. We are given the binomial expression a squared plus b cubed raised to the fifth power. Okay. So the value of n here will be equal to 5. So if we try to expand this according to annotation number 1, the total number of expansion should be 6. It will be 6 terms. Right? And what are the coefficients of the 6 terms? Okay, to determine the coefficient of the 6 terms, we will build the Pascal's triangle. This is 1, 2. It's the same as the equal. 1 plus 2 will be 3, 2 plus 1 will be 3, this is 1. 1 again, 1 plus 3 will be 4, 3 plus 3 will be 6, 3 plus 1 will be 4, last 1 will be 1. Okay, next is set. Par n is 1 and 1. Okay, 1 and 4 will be 5, 4 and 6 will be 10. Okay, 4 and 6 and 4 will be 10 again, 4 and 1 will be 5, last 1 is 1. So this is for n is equal to 5. So the coefficient of the binomial expression a squared plus b cubed will be with the values, the first term has a coefficient of 1, second term will be 5, third will be 10, fourth will be 10, fifth will be 5, last one will still be 1. Okay, let's try to expand now. The value of a here from our original representation is actually a squared, and the value of b is actually b cubed. So instead of using this one, the given problem is of this. Okay? So don't just follow this, because for the given problem, this is a squared and this is b cubed, and from our original representation it's just only a plus b, right? So the new a here will be a squared and the new b will be b cubed. Okay? Okay, expanding. The first coefficient is actually 1, right? This is 1. The first binomial is actually a squared. It will start with n. N is 5, right? And the second binomial is b cubed. The power will start with 0 for the second term, so this is 0. Okay, let's try to check it. For the first term, the power is 5. Then it goes to 4. It goes to 3. It goes to 2. It goes to 1. Then it goes to 0. That is, for the first term, it will be from n, okay, till 0, where n is equal to 5. So we started with 5, right? For the second term, it will be in this old ascending order, increasing. So this will be b cubed raised to 0. This is start with 0. Next one will be 1. Next one will be 2. Next one will be 3. Next one will be 4. And the last, okay, will be 5, equal to the given n. So it starts with 0, then reach 5. For the coefficients, we have determined the coefficients already. First term, the coefficient is 1. Second term, the coefficient is 5. Third, the coefficient is 10. Fourth, the coefficient is 10. Fifth, the coefficient is 5. Right? And the last part, the coefficient will be 1. Simplifying this one, this is b cubed raised to 0 power is actually 1. Okay? So this is 1 times a uh, we use the laws of exponents here. 2 times 5 will be 10, right? So the first term of the expansion will be a to the 10th power. Okay, using laws of exponent. We passed that one on our lesson. Next one. 2 and 4 will be 8. And 3 and 1 will be b cubed. So this is 5e to the a times b cubed. Next one. The coefficient will be 10, right? 2 times 2 will be, what's it? Third term. I think I made a mistake here. No. Where's the third term? This one. This is the third term. The coefficient will be 10. 2 times 3 will be 6, right? This one. We are here. And 3 times 2 will still be 6. Fourth term. The fourth term, 2 times 2 will be 4. Okay, and 3 times 3 will be 9. The coefficient is 10. Fifth one. Where's the fifth one? This one. 2 times 1 is 2. And 3 times 4 will be 12. So the exponent of b will be 12 and the exponent a will be 2. For the last part, a cubed to the 0 power is 1, right? So this is 1. 1 times 1 will be 1 times b to the third power. Raise that again to the fifth power. 3 times 5 will be 15. So the last part is actually b raised to 15. So this will be our final answer. Okay, as simple as that one, if you know how to build the Pascal's triangle. Okay guys, good morning from Los Angeles. This is Professor DavidJDelosReyes. That's the solution of the expansion of a binomial expression by using Pascal's triangle. First one, build the Pascal's triangle, determine the coefficient, then try to expand, okay? One by one, but be sure to carry the proper exponent for the first and second terms. Okay, good morning from Los Angeles, Professor DavidJDelosReyes.